There we go. Okay, so in the topics of science class on the right-hand side in the upcoming list, you'll see one thing listed there. It says Lycoming County Bridges Project. So this is a project that will start today, and you have until Tuesday to complete it. This is the last thing that you need to do before break. So let me show you what you do. You can find it here in the upcoming list. You can also find it in the folder with the remote learning materials. So in our list of projects that we've been working on, there's a purple folder that says remote learning materials, the current unit. All the time in the plan for the week, there's a recording of the Zoom for each day's class. This one here says Zoom recording. I'm actually going to upload this Zoom recording and put it there. Anyway, so I'll introduce the project, and then there's time to work on that project. You have until Tuesday to complete it. It doesn't take too long to do, though, so you can probably even get it done during this period. All right, so it's in here as well in the remote learning materials folder and on the upcoming list. When you click on the assignment, it's a Word document that's just like all the other classes you've had and projects we've worked on as a SharePoint file in the OneDrive. Once you open it, it's your copy, and it'll everything you type in here will automatically be saved. When you submit it, I'll be able to read it. So there's a website at the top here. It says pghbridges.com and then /basics.htm. Okay, this is a site actually about the bridges of Pittsburgh. And Pittsburgh, Pennsylvania has a bunch of nicknames. People call it the Burgh, people call it the Steel City, but it's also known by some as the City of Bridges. That's kind of a trivia thing, but it's called the City of Bridges mostly because the city center itself is located at the confluence of the Allegheny and the Monongahela River, where those two rivers form the Ohio River. And as a result of there being these major rivers right in among the city itself, there are a number of bridges that have to cross each of the rivers. Many people have to travel from maybe from the north side here onto the point and then into the South Hills, have to cross a number of bridges. There's also a number of tunnels and stuff. So you can read and see stuff about the bridges of Pittsburgh, but if you go to that site that's in the document, pghbridges.com, basics.htm, it just ends with M, doesn't have an L at the end. It'll take you to a page that shows you stuff about the basics of bridge design. And the first thing at the top, the four main factors used in describing a bridge are right here: the span, the material, the placement of the travel surface relative to the structure, and the form of the bridge. So those are the major ways that you can describe individual bridges. We're going to have a simple span for getting across our bridge tester in the classroom. Our material is always going to be made of balsa wood. The place that the load tester can be a number of different places, and then you can take just about any form. But so what this site will show you is a whole bunch of different ideas about different types of spans, and then different types of configurations for bridges, and then different shapes of bridges. And there's a whole bunch of different shapes of bridges, and they can even be more complex than the shapes that are listed here, but those are generally the different types of bridges. Some of them that you'll recognize as bridges that you might travel over or travel through. And so this is the site that's really good, that shows basic types of bridges themselves. If you are in the Bridges of Lycoming County, so again, the site is listed right here. You can use that, like copy and paste that into maybe another tab on your browser. So you've got your Bridges of Lycoming County document, and then the pittsburghbridges.com website on another tab. And so I write here that Lycoming County has lots of bridges that cross our rivers and creeks. Some are overpasses for highways, or highways go over other highways, but generally our bridges commonly go over bodies of water, over the Susquehanna River, over the Loyalsock Creek, over the Lycoming Creek, over other creeks, smaller creeks and stuff. So in this, I've got pictures of different bridges around the county. This is the new railroad bridge that crosses from Williamsport over the Loyalsock into Montoursville. The bridge was actually destroyed in a flood. The old bridge was destroyed in a flood, and I believe it was 2011. You can see the green bridge here, which is the 3rd Street Bridge going from Williamsport to Montoursville in the background. But this bridge will match one of the types of bridges that's in this bridge building, or the bridge types. So down in here, there's a bunch of different shapes of truss bridges, and you'll see a bridge type that's going to be very close to this type of bridge. If it's not exactly the same, that's okay, because there are different modifications that designers use to make bridges. But once you figure out what kind of bridge that is, you can type the type of the bridge in there. The 3rd Street Bridge, which is the bridge that goes from Williamsport into Montoursville, actually has 3 separate spans. They're identical, or nearly identical. I believe they're identical. But this is one of the spans, and you can see the shape of it. It's got an arch on the top and these crisscross patterns. This is an entirely different type of bridge, the Upper Boudines Bridge, and this is a new bridge. And it's not made of steel. It's primarily a concrete structure, but it has this one big arch underneath it. The Upper Slate Run Bridge, so this is up on Slate Run. It has a completely different pattern altogether with all these crisscrossing things. This is a bridge that crosses Pine Creek in Jersey Shore, and it has this curvilinear shape, almost looks like an eye. And then the Market Street Bridge, which you're familiar with, goes from Williamsport into South Williamsport. There's a covered bridge in Cogan House Township, which looks like this. So in the document, I've got a bunch of different types of common bridges that have a variety of shapes and a variety of materials in our county. And once you describe the different factors that are used in describing a bridge, you can match up the type of bridge with the general design name. So like if you think it's a lenticular truss bridge, it's a lenticular truss. If you think it's like a Fink truss, then it's a Fink truss. They won't be precisely the same. They might have different numbers of members, different numbers of parts of the bridge, but they'll generally look pretty similar to the ones that are in that document. Besides that, the Bridges of Pittsburgh website is pretty cool because it shows all kinds of different sorts of sizes and shapes of bridges. And besides bridges in Pittsburgh, there are also a whole lot of tunnels, and going through mountains and going over rivers, and is a big engineering challenge. And you'll see in some places, some bridges are preferable in shape and size to other types of bridges. What the designer tries to do is make the bridge uh, so that it can carry the correct type of traffic, span the distance it needs to span, have the good clearance underneath, have a weight capacity that it needs to have, and have a useful, suitable life. And all that at the lowest price you can do it. So everything in engineering and design is a matter of compromise. You'll see that, like, as you build the balsa bridges when we get back to school, the more material you use, the greater cost there'll be, and the more the bridge itself weighs, and the longer it takes to build. If the bridge is built with as little material as possible, it saves on the cost of the bridge, and it reduces the manufacturing time. There's also a little bit less maintenance generally. So you cross bridges all the time. You may not realize it, because sometimes, not to say bridges are hidden, but there'll be culverts or cricks that go underneath the bridges. Actually, as you drive back and forth and around to Williamsport, there are cricks that come in from the north side of Williamsport and pass entirely through tunnels underneath the city, and have discharges into the river. So anyway, that's what you need to do. You can get started on that now, and then you just need to have it complete by Tuesday. So again, let me go back to our Schoology page. On the right-hand side, oops, that's not it. There we go. On the right-hand side of the list of upcoming things, here. So like under updates or whenever you log into the class, on the right-hand side, it says Lycoming County Bridges project, and you have until Tuesday to complete that. You have to make sure you log into each class every period, every day. Log in on Monday and Tuesday. I'm working at home right now, but we'll be back in school. Teachers will be back in school on Monday. Let's see. Okay. All right. So I see your message. Need help on the El Nino web quest. Okay, I can help you out with that. All right. So if you don't have any other questions about the, let's see, on the Lycoming County Bridges project, I have you marked down for attendance for today. You don't have to stay in the Zoom. I'll see you on Monday. Let's see. Okay, so the El Nino web quest, what kind of help do you need? Is it like not showing up, or is there parts of it you don't understand? You can type it in the chat or you can turn on your mic. Third question. Okay, let me look. Okay, let me go in here. Okay, so yes, for the third one, there's a schematic section, a schematic diagram section on the site, and we want to know like what phases is the temperature the same from east to west across the equator? When or during which phase do ocean currents move to the west? And in which phase or phases do you expect more rainfall in the Western Pacific? Okay, so let me go to the site. Let's see, bit.ly. Okay, the schematic diagram section on the right-hand side of the page, there's a link that says schematic diagrams, and I'll show you what you're looking at here. Okay, so for each of the diagrams, the equator, which runs from here to here, that's like at the center of the Earth going around the middle of the Earth. Let me show you on a globe. That'll maybe help you out. Not sure why my web connection's a little bit slow today. Okay, so we're dealing with the Pacific Ocean, and the equator runs right around the middle of the Earth, kind of like a belt. And the eastern part of the Pacific Ocean, here by South America, over to the western part of the Pacific Ocean by Indonesia, that's on this diagram as here and here. So this is North America. You can see, like, this is the United States. There's Florida. This is Mexico, the rest of Central America, and this is South America. And then this is Australia and parts of Indonesia. So the three different conditions, the El Nino, normal, and La Nina, the things you see in the diagram include the water temperature. So the water temperature, the closer to red it is, the warmer the water. And then if it's blue, the water's cooler. So the first part is like, during which phase is the temperature about the same from east to west? So what I mean is, if you look at the equator going from east to west, like straight across like this, when is the temperature more consistently the same across here? Is it when you have El Nino, or is it during normal conditions, or is it when you have La Nina? And if there's a lot of different colors, it indicates a lot of different temperatures. So here the water's very cold where it's blue, and red is like where it's very warm. The other things that the diagram shows is the direction of the ocean current. So here if the arrows are pointing to the right, that ocean current is heading to the east. In other words, the water is actually flowing in the ocean in this direction from west to east. In these two cases, the water in the ocean is actually flowing toward the west. There's a current, so the water in the ocean is actually going this way and this way. And then the third part is like, during which phase or phases do you expect to see more rainfall in the Western Pacific? So the Western Pacific is over here. This is the Eastern Pacific. That's the Western Pacific. And you can see in these diagrams where there are clouds that are raining. So here the clouds are raining more in the middle of the ocean. And here, the clouds are raining more in the western part of the ocean. So where the rainfall is more common is wherever the clouds themselves are. So I don't know, it could be that maybe this is the place where you need to navigate to get to the schematic diagram, but that's what the colors tell you about temperature, the white arrows tell you the direction of the current, and then the clouds show you where the rainfall is actually taking place. Let me look. So El Nino is warm, right? Yeah, so like when it's El Nino, you get warm water here in the eastern uh, Pacific Ocean, close to North America. See, it's kind of like orange. But then when it's La Nina, it's like blue, which is cooler water. So the El Nino is warm, a warm water current that flows to the east. And La Nina happens whenever the cool water current flows toward the west. All right, so hopefully that helps. Do you have other questions, or did that not make sense? Okay, cool. All right, any other questions from anybody? All right, so if you don't have any other questions, you can work on the Lycoming County, or the Bridges of Lycoming County project. And if you do have questions, you can send them to me through Schoology, or I'll be here in the Zoom for a while. Make sure you turn on your mic and say something so I know, or like notice that you're here. And then I'll see you on Monday. I can take questions on Monday and Tuesday, but the Lycoming County Bridges project is due on Tuesday.